how to do a hypothesis test by using the critical region method. And so they establish what we call a rejection region, and then from the rejection region, you make a conclusion, okay? And so they don't use a p-value, and so I'm going to go ahead and get into this. Example 1 regarding sunspots, let x be a random variable representing the number of sunspots. Random sample 40 such periods gave the number of sunspots per period. The raw data is given example 1. The sample mean is 47.0. And then you have sigma is known, so we're going to use the z procedure. It's thought for thousands of years the mean number of sunspots is mu equals 41. This indicates different. So basically, like you've got you can copy this down if you want. It was mu equal to 41. And you're trying to prove it's greater than 41. We already did this example here. Okay. And so here's how the rejection region method works. You use your alpha and you use the alternate hypothesis and you kind of establish a region where you would reject. Okay. And so I'm going to draw a normal curve where 0 is in the middle because it's a standard normal curve. And I want to know what z value I need to be in the rejection region. It's greater than, so it's a right-tailed test, so it's going to be in the right tail I'm rejecting. And so I need to know what z value would be here, okay? Now this 0.05 tells you what area, the area of the shaded region. So the area of the shaded region is 0.05. If you don't like this method, I don't blame you. It's not my favorite method to do. And so that what I have to do now is I have to find will be the critical value. I'll call it z star. So how do I find z star? I could use my calculator. I can go to inverse norm. I could also use a z table. I'll look at the area. So I'm wanting to know this z value. That's what I'm trying to find. Okay. So inverse norm. The area, I could use the right area, 0.05. 0 and 1 for the mean standard deviation. And it's a right-tailed test. Or not right-tailed test, but right-tailed area. This is a right-tailed area. And it's 1.645. So z equals 1.645. Now, what you have to do next is you have to calculate the test statistic for this problem, which, let's see, the test statistic, we already know it. Let's go back there. The test statistic is 1.08. 1.08. So now, let's think about where 1.08 is. 1.08 is in between 1 and 1.645, but it's not quite to that point. 1.08 would be around right here. It wouldn't quite dip into this area. So if it dips into that area, we say that it's significant, and then we reject Ho. If it does not dip in that area, then it's not significant. We fail to reject Ho. So this one, is this in the critical region? You would say no, not in the critical region. So therefore you would fail to reject Ho, and then it would be not significant, and you wouldn't have evidence. Not significant, and then I'm just going to put note insufficient evidence. Okay. So that's how that works. All right. On your homework, you'll have to establish what is the critical region. And so if I'm establishing what the critical region is, the critical region would be a test statistic that is greater than or equal to 1.645 and less than or equal to, there's no bottom area, so the less than or equal to, you'd put none. So it's greater than or equal to 1.645, less than or equal to none. There's no boundary down there. And so that's how you establish what the region is. Our test statistic does not dip into that, so we would fail to reject not significant. The p-value, remember, was greater than alpha, so your decision you make here would be the same as you make using the p-value. I like the p-value a lot better.